Let's get started this morning. Welcome to Autodesk Virtual Academy, brought to you by your friends here at Kativ Technologies, and today by our friends over at Autodesk as well. I'm Nigel Labayak, one of the customer success managers here at Kativ Technologies. Today, like I mentioned, we've got a couple of people on board with us. We've got Alex Alvarez, one of the AEs here at Kativ. How's it going, Alex?
Not too bad. Pretty good.
Calling in from the office. I like that.
Hmm.
And in addition to Alex, we've got Justin Ferguson, one of the technical specialists at Autodesk. Justin, how's it going?
It's going pretty good on my side.
Awesome. Great to hear. I'm really excited to see what you guys have to show us. As you can see on the screen, we're going over PowerMill 2021. We have gone over the what's news for a number of products in the Autodesk, release of products. So that includes AutoCAD, Inventor, Vault, and then we've done two sessions on Fusion 360, one on the modeling side and then one more on the manufacturing side. So if you missed any of those, go ahead and take a look at our YouTube channel. Those will be up there to review once you need them. Without further ado, I'll go ahead and pass it over to Alex and Justin. They know a lot more about this than I do, so I'm going to defer to them for the rest of the presentation. Take it away,
Awesome.
Alex.
Yeah, no, thank you for that, Nigel. So exactly like you said, right, we're going to be talking about some of the 2021 highlights for PowerMill. And again, just making sure that everyone understands PowerMill has been released, already actually released on May 13th. If you do need help with installing the software, again, if you have an active subscription or maybe you're on the maintenance plan and you need help installing, or maybe you need help just accessing the software, let us know. Give us a call. We're here to help you guys. Again, if you guys want to do it on yourself, you guys can access it through manage.autodesk.com/home or the Autodesk app as well. So again, just wanted to get that out of the way. Again, for today, like I said, we are going to be talking about PowerMill 2021 highlights and really focusing around what are some of the main improvements that come with PowerMill 2021. Again, we're going to be focusing on speed, quality, and reliability. You'll see that most of this presentation is going to revolve around the speed improvements. Again, for today, we're going to be just covering through a few slides, going into the actual PowerMill 2021, showing those improvements live, and then we're going to have a Q&A session at the end of the presentation. So if you do have any questions throughout the presentation, again, feel free to ask away, and then we'll answer them towards the end of our presentation here. So like I said, most of the actual improvements are going to revolve around the speed improvements, specifically on some of the toolpath calculation times. Now, enhancements, for some of these toolpaths, such as the area rest clearance, the rest area clearance, the area clearance toolpath, the raster toolpath. So some of your most commonly used toolpaths have seen some pretty drastic improvements in terms of calculation times. Commands such as your stock model boundaries, when it comes down to opening large PowerMill projects, right? The model filleting toolpath as well. So there's a lot going on here, and again, there's a lot of speed improvements that took place with PowerMill 2021. Now, we can't just say that that there's speed improvements without actually showing the actual data that comes with some of the toolpath improvements here. So we do have just a little bit of data here to show. Again, this is comparing PowerMill 2021 with versus PowerMill 2020. Now you'll see that one of the main ones, or one of the biggest improvements here, is going to be the area clearance and the rest area clearance toolpath. Now again, what's taking place here is that you actually see improvements to multi-threading, and as a result, you're going to see improvements of around 30%, roughly around that toolpath. Now again, we're actually going to demonstrate this. We're going to demonstrate a comparison between 2020 and 2021, and again, Justin is going to demonstrate that live as we're kind of doing some of these improvements. Again, things such as your multiple finishing strategies. Again, the way that they're using the cores or threads have also been improved. Again, they've seen improvements up to 7%. Your stock model boundaries, right? So the core algorithm actually is showing a increase up to 20% as well. Now, one of the biggest things here that you'll see is opening some pretty large projects. As we know, some of the PowerMill projects can get pretty large in size. So in this specific test, what Autodesk did is they actually opened projects with up to 2,000 features, maybe even more features than that. And they saw times reduced up to 50%. Now that's huge, right? You don't have to wait and sit for some of these large PowerMill projects to open up. Again, we are seeing some pretty drastic improvements on the opening project side. Again, just a little bit more data here. Again, this chart is going to show the improvement for the faster area clearance. So again, this chart is going to compare not only 2020 versus 2021, but it's actually going to compare all previous PowerMill versions. You can see to date, 2021 is going to be pretty faster than the previous versions here. Again, 23% faster than 2020, 17% faster than 2019. So you are seeing some pretty large gains in terms of improvements and performance when it comes to the 2021 version. Now, again, still talking about speed. Like I said, this whole presentation is going to revolve mostly around the speed improvements that took place inside of PowerMill 2021. Now, this chart is going to compare calculation times for the stock model boundaries. Again, this is a test done using different projects, and as you can see here, again, most of the improvements and the drastic improvements were done on 2021. You can see 2020 there's a slight difference there as well, but again, nonetheless, it's still 2021 is still the faster version as we're moving forward here. So again, a lot of data. We don't want to just say that we improved the actual performance of 2021. We actually do want to highlight the different versions, and we also want to highlight the actual data that comes along with these improvements. Now, this is actually one of my favorite, kind of one of my favorite commands here. So again, model filtering. This was first introduced in PowerMill 2020. For those of you that aren't familiar or as familiar with model filleting, essentially what it's doing is it's automatically adding fillets to the internal corners of your CAD model during calculation of these toolpaths. Now, again, what does this do in the long run? Well, the addition of the geometry is actually used to prevent tools from cutting into large areas of the stock, right? So what is that going to cause? So that can cause tool chatter. It can actually shorten your tool life. Or it can even actually result in tool breakages as well. So again, this feature was introduced in PowerMill 2020, and as we're seeing here in 2021, this actually got some pretty drastic improvements as well. More on the speed side, but as well, it was added to most of all of the 3-axis toolpath strategies. So again, before it was limited to just a few toolpath strategies. Now, like I said, it is added to all the 3-axis strategies that PowerMill has to offer. So pretty big move here. Now, again, just showing just some additional data here on the faster project opening. Again, it's seen improvements on how long it takes to open projects. Now, you'll see that comparing 2020 versus 2021, right? There's a 27% increase, but again, 2016 was actually a pretty good year for PowerMill. And again, they're closing that gap between 2016 and 2021. So comparing 2021 to some of the more recent versions of PowerMill, you do see some pretty drastic improvements, but again, closing that gap with PowerMill 2016 when it comes down to opening some of these projects. Automatic collision avoidance. This is something that we're actually going to show. Again, some of the improvements that took place, where we're seeing typical time savings of up to 20% in terms of calculation time and performance improvements. Again, Autodesk actually does do beta testing before releasing these. So they pick a handful of customers, they have them test 2021. They get some of the data that they collected, and then they compile it, and then they start sharing the data. So again, one of the customers actually reported seeing 65% faster toolpath calculation when using automatic collision avoidance. So again, pretty drastic improvements. Like I said, 2020 versus 2021, there's going to be a lot of time savings when it comes to that switch, or when it comes to upgrading to 2021. And here again, you can start seeing just a little bit more data just comparisons between 2020 versus 2021. The verification has seen some improvements. Automatic collision avoidance, like I just said, on average 19% when working with this specific part. Steep and shallow has also seen some improvements. Like I said, the finishing strategies, which steep and shallow is one of them actually, has seen some pretty drastic improvements as well. So you can see that for this specific part, we actually saw a 12% difference with corner filleting on.
One thing to note here is that we've seen the differences between the speed going from 2016 into 2017, 18, 19, 20, 21. And the slowdown that was seen was because we were improving the quality of the calculations and the quality of the toolpath that was produced. And that was just requiring more processing power. And so now, as we've worked on the multi-core, multi-threading to allow these processes to be calculated safely, to give better toolpath, to allow for more robust calculations while also being quick. And so we don't want to sacrifice the safety of the toolpath. We don't want to sacrifice the integrity of the software just to make it fast. We want that first, and then we can make it fast. And that's why it's taken a few years to get that robustness followed by the speed.
Yeah, that's perfectly perfectly said there, Justin. Again, the main priority here is going to be reliability, right, and how safe you can produce the toolpath, and then next after that is going to be the speed that comes along with it. So again, here on this chart, we're going to be showing some of the comparisons for this actual part here as well. So we have an area clearance toolpath, we have a rest roughing toolpath, and again, some of these differences. Now, this time is going to be seen in seconds. Like I said, we are going to be seeing some of this data or some of this workflow seen live. We're going to actually show the differences between some of these toolpath calculation times here shortly. Okay, so not only are we seeing speed improvements, but we're also seeing reliability, and we're also seeing, like I said, just some additional improvements done to the actual toolpath algorithm themselves. For this one, right, so we're going to see automatic collision avoidance. Now, what in PowerMill 2021, what takes place now is that the automatic collision avoidance actually finds even more collisions that may be or may have been missed in previous versions. Again, significant improvement, right? It's what it's also doing is it's also adding more points to the toolpath itself. Again, what this is going to allow to do is produce smoother, more predictable machine motion, which in the end is going to result in a better surface finish. Now, this is something that we're actually going to demonstrate as well, and something that you can see firsthand. So like I said, automatic collision avoidance not only got improvements to on the speed side of things, but it also they also improved the actual algorithm that's driving this toolpath. Steep and shallow also saw some improvements. So again, we saw that there was a faster calculation time. The steep and shallow actually, the algorithm saw some improvements as well in the terms of if you can see here, there was some slight fragmentation taking place inside of PowerMill 2020. PowerMill 2021, again, they improved the algorithm, and you no longer see those small fragmentations that take place. Now, fragmentation, what that does is it's essentially adding more machining time, and it can cause for a poor surface finish along the top of that part that's being highlighted. So again, this is something that we're also going to show firsthand, and then that way you guys can take a look at what's taking place behind the scenes here inside of PowerMill 2021. So with that, let's go ahead and jump into the live demo. Like I said, we're going to talk about the steep and shallow fragmentation first, and then we'll go ahead and jump into the automatic collision avoidance, and then Justin will do his part and show some of the speed improvements on his end. So starting off here, again, made sure to actually specify what software was which. So here we're inside of PowerMill 2020, and we can see that this is a steep and shallow toolpath, right? So we're going to zoom in here slightly. You can see the fragmentation here taking place, and again, it's you know, it's kind of hard to see, but if you zoom in, you can kind of see what's going on, right? So the tool is going to be going along the top surface here, and it's going to try to retract and recalculate, or kind of reposition itself. And reason for that, if we turn on the machine shading here, we can see that there's actually a check surface on the top of that surface. Now, essentially what we're doing is we're saying stay away from that surface for whatever, you know, the given parameter was. And here what it's doing, again, the toolpath algorithm is allowing for this fragmentation to take place. Now, if we simulate it, we can better see what's going on. So we're going to go around the part, doesn't look too bad. And as it begins coming around this specific area, you can see some of the tool lifts and some of the fragmentation that's taking place on the toolpath itself, right? So again, like I said, this is going to cause a longer machine time or machining time, and it's also going to cause for a poor surface finish. So you might have to come in here, maybe even change your strategy, or you might have to edit the toolpath, which you can absolutely do. If you wanted to, you can go in here, you can select a piece of the toolpath, and then you can delete the selected toolpath, right? Deletes the toolpath. You can delete specific sections if you want. You can maybe change the height of what you're trying to machine up to, right? So there's a lot of modifications that you can do to actually modify this toolpath and get rid of this fragmentation. Now, the point here that we're trying to get across is that inside of 2021, there's no need to do that. You're essentially just going to program the same exact toolpath, and this here again is the same exact project. We have the same exact toolpath. What we can do is we can actually clone the toolpath. We're not going to change any settings here, right? So we're going to go ahead and clone the toolpath. We can give it a new name just so we can see the difference between these two. And we're going to go ahead and calculate this. And then there's the steep and shallow 2021. So again, no toolpath modifications. I didn't change any settings. It was the same exact toolpath that was calculated inside of 2020. And inside of 2021, we actually see that improvement. And if we zoom in, we no longer see that toolpath fragmentation taking place. Right. So again, just that algorithm improvement that took place inside of PowerMill 2021. I'm going to go ahead and actually show the collision checking avoidance here real quick, right? So we're going to go ahead and load the project real quick. And again, if you guys have any questions, anything that you guys want to see, maybe there's a specific improvement that you want to see and we're not covering, again, let us know inside of the actual chat, and we can go ahead and take care of that for you. Now, again, one of the things inside of the collision avoidance was not only speed, but you can actually see significantly more points added to the toolpath itself. So I'm going to go ahead and activate, again, very similar to what we did before. We have a 2020 version of the toolpath. We have a 2021 version of the toolpath. I'm going to go ahead and activate this specific toolpath and then calculate it. Now, again, if you guys aren't as familiar with PowerMill, again, you do have some safety measures kind of taking place in the back end here. So you can see that the toolpath hasn't fully been checked yet. Right? It doesn't know the safety status of the tool, and it doesn't know if it's going to collide in terms of the holder. So we can actually go ahead and do that separate from the toolpath itself, meaning you don't have to recalculate the toolpath. You can really just do that kind of on the back end, like I said, or you can do that separate from the actual toolpath. Again, so without having to recalculate the toolpath, you can check for collisions. You can go ahead and specify what you want the holder clearance, the shank clearance. Notice that no collisions were found. And you can actually check for gouges here as well. And you can specify some of these parameters. You can set them. And if PowerMill doesn't find any collisions or any gouges, what you get is you actually get a blue check mark now indicating that you have a safe toolpath. Now from here, let's go ahead and just get a better angle here. It looks slightly different, right? So there's kind of a lot going on here, but that's because we have the points enabled inside of the toolpath itself. Now again, these points these points themselves are actually what's getting spit out on the G-code side. So again, if you ever want to take a look at what's going on, how large maybe your toolpath size is going to be, this is one way to gauge, right? Is how many points you're going to have on the toolpath itself. Now I'm going to go ahead and turn on contact track just to make it easier to visually see what's going on here. And I'm going to do the same thing for the 2020 toolpath. Right, so again, same exact toolpath, turn on contact track. And now without moving the model, so we have 2020 active, we calculated 2021. Now it's a little hard to see, but you can see some additional points being added to the toolpath itself. Right, so I'm gonna go back and forth.
This is especially apparent on that right side where we're seeing that first tip away from the tool and the tool holder to avoid a collision.
Exactly.
The extra points allow for a little bit smoother motion and a better interpolation that the machine can take along those points.
Yeah, and as we zoom out here, you can kind of see some of the more areas that more points have been added to. So again, exactly like Justin was saying, right? So this is essentially what this is doing is it's allowing for a smoother motion of the machine, ultimately giving you a better surface finish if it's not as jerky or if it's not jerking around around certain areas of your part. So again, smoother motion. What we just covered here was the automatic collision avoidance. We covered the algorithm improvement for the steep and shallow toolpath as well. I'm going to go ahead and hand it over to Justin here so you can show some of the speed improvements. And Justin, if you don't mind sharing your screen.
Absolutely. So one thing that you'll notice from both Alex and I presenting these materials is that a lot of what we're showing is run based off of macros, and a lot of the timing that was done to show the improvements between the 2020 and 2021 versions, and even further back to 2016 versions, it's using macros. And so as an example, I have the one that we're using today, and this is looking for each toolpath in the folder. It's using a little bit of logic. If the toolpath is not calculated, what are we gonna do? We're gonna activate the toolpath, we're gonna start a timer, and then we're gonna calculate that new toolpath, the toolpath that was not calculated before. And when it's done, then we're gonna rename it with a new name and it'll have the time there. So with this, we've got PowerMill 2020 started with the same project, same macro. You'll notice in the lower right corner, the icon changes from 2020 to 2021 when I switch between the two. So you can keep an eye in that lower right corner to see where we are. But we'll start with 2020, and we're going to calculate the three tool paths that we have for this to keep the time down, not needing to take up too much of your day. And so we're going to start with an area clearance toolpath, and then a rest clearance toolpath, and then the last one is actually going to be another rest toolpath, but it's going to be finishing up those corners. So by pressing resume here, we start that timer and start calculating these toolpaths. Now, if you have any questions about automating the software, such as we've done to do this timing, you can reach out to Alex and we can talk you through that, provide training for you, and even, see what's possible within PowerMill to be able to automate it for you. Now, as this calculates, I wanted to share with you that, the computer that I'm working specifically on is an Intel Core i9, is a multi-core processor. I have 6 cores, which are hyper-threaded multi-core, so I have 12 logical processors. It's got a base speed of 2.9 gigahertz, and I have about 32 gigabytes of RAM on this computer. Now, the Intel cores allow for that turbo boost, so that's where you'll notice this speed goes up above that 2.9. So there's the ability for this computer to actually utilize more speed of this processor for short durations. And that's exactly what we're looking for this type of a calculation. Speed up the processor, get a little bit more out of it, generate a little bit more heat. Then when the calculation's done, it turns off the high speed and is allowed to actually return to a stable temperature. And that's all based on what Intel can do, but really it's just to tell you all about the processor that I'm using, and so that the speed improvements that I see are going to be different based on the specific processor and the specific computer specifications that you have.
Yeah, and one thing I wanted to point out too here as well is, again, there's a lot of automation power that you can do within PowerMill. So again, Justin just showed the macro and kind of some of the data, some of the information that he actually used to calculate that. Like I said, if you guys are interested in automation, maybe you guys are interested in learning more about the different capabilities within PowerMill. Let us know in the chat. There is going to be a survey at the end of the webinar that you can fill out, and you can let us know exactly what you want to see next, whether it's PowerMill, whether it's FeatureCam, whatever topic you guys want to see next. Let us know, and we can definitely provide webinars around those topics.
So while Alex was mentioning that information, I've switched over to PowerMill 2021, and we're calculating these toolpaths now. It's going to be about a minute or two to get these calculated. But one thing that you'll notice from the previous PowerMill 2020 is that the total cumulative time for that 3 toolpaths to calculate was 119 seconds. So for this to be able to move on, we're going to continue to see, and PowerMill 2021 has finished the first calculation, these and links for the second one, and now our third toolpath. All right. So now that we've got that, we've got PowerMill 2021 that shows the total cumulative time is 91 seconds. And if we go back to 2020, we see that's 119 seconds. Now we can compare the different toolpaths. You see that rest area clearance is 49 seconds versus 56 in 2020. 2021 had 32 seconds on the corner rest and 53 seconds on 2020 version. Now, if we use our calculator for this, we can take the time in our 2021 version, which was 91 seconds you see here. We'll take that 91 and we'll divide it by the 119 seconds that you see here, 119, not 118. And we see that it is 76% of the time from 2021 to 2020, which means that we have a 24% increase from one software to the other, just calculating these small toolpaths. What I would consider small toolpaths was just a couple of a minute per calculation time. You're not looking at hours and hours and hours, but as this scales up into 3, 4, 5 hours calculating these toolpaths because of the models being so big, you can see where the true savings is. So Alex, I'll turn it back to you so that we can continue on.
Yeah, perfect. And that was a perfect demonstration there as well, Justin. Like I said, we could have pulled up a video and we could have showed you kind of what Autodesk had already done. But again, we did want to show that live. That way you guys were able to actually see what was taking place. Not only see the actual speed improvements, but actually see the power of some of the automation that's taking place inside of PowerMill, right, with the use of the macros and the use of the different language that you can actually program it with. Okay, so again, we just covered a handful of actual improvements here for PowerMill 2021. Again, you saw some speed improvements. You saw a little bit of toolpath algorithm improvements as well. There's a lot more that took place inside of 2021. Again, so the GUI robustness was also added there as well. Faster additive profiling strategies is a pretty big one. Again, if there's anyone interested in additive capabilities, that's something that we can also cover and we can also discuss. We are going to leave, or I am actually going to leave my contact info here at the end. That way you can reach out should there be any additional questions at the end of this. But again, just a quick summary here of what PowerMill 2021 is. So again, we saw some speed improvements. Majority of the speed improvements were around the toolpath calculation time, stock model boundaries, project opening, right? That's a pretty big one as well. Safer collision avoidance. So again, more collisions have been avoided. And not only that, but you also see more points being added to the automatic collision avoidance, right? So again, automatic collision avoidance is the use or the ability for Autodesk PowerMill to actually detect some of these collisions and apply 5-axis motion to that toolpath to avoid any possible collisions. Steep and shallow, we demonstrated the actual the power behind some of the toolpath algorithm. How again there's less fragmentation, ultimately leading to less toolpath modification, and again less time spent trying to perfect that toolpath. Like I said too, the additive manufacturing is a pretty big one. So again, if you do want to see improvements on the additive manufacturing side, again, that's something that we can discuss, and we can take this offline, and we'll do a more of a personal demo if you're interested in the additive portion of PowerMill. Again, if you do want to learn more about this, there's an actual 2021 write-up that you can see exactly what the improvements have been. It takes you to YouTube videos around some of these additional improvements. So if that's something that you want to see, let me see if I can actually add this to the chat real quick. That way you guys have the ability to go in there yourselves. So I'm gonna go ahead and add this real quick. Again, guys, feel free to check that out. If you guys have any questions around PowerMill 2021, like I said, you guys can reach out to me, and we can go ahead and take this offline should you have any additional questions.
So, have a great day. Thanks so much for joining us.
Yep. Thank you, guys.
Absolutely. Thanks, everybody. See you soon. Bye-bye.